Right, welcome to additional mathematics. The first section we're going to look at in additional mathematics is going to be functions. And before we explore the world of functions, the first thing we'll look at is something called mappings. So, if we take some number, and we can call this number, if we want, we could call it the input. And if we applied some kind of mathematical rule to it, so that could be squaring, multiplying, dividing, any of the mathematical rules. The result of all of that is what we call the output. So how mappings work is we can represent mappings in one of three ways. We can either have a mapping diagram. So we can consider some input values 1, 2, 3, and 4. And if we applied some mathematical rule to it, we would get an output. So if I gave some output values, we could see that the mathematical rule being applied to all the input values is we're simply just adding 1. So in a mapping diagram, we could express it like this. Alternatively, we could express this algebraically. Now, we've already learned function notation when we learned functions in IGCSE. So there's two ways we can represent this. We can either say that we have x as an example variable, and we can say x is such that it's mapped onto x plus 1. In other words, for whatever input value, we just simply add 1 and we get the output value. Another way of writing this notation would be function notation, and that would be f of x equal to x plus 1. So x plus 1 is a function, or f of x is a function of x plus 1. The final way we can represent this is graphically. So graphically, if we look at this, f of x, or x mapped onto x plus 1, this is a linear function, and that can just be represented as a straight line with a y-intercept of 1 and an x-intercept of -1. And so it would exist over here. So graphically, we can represent this as well. Now, usually we would label the vertical axis as y. In this case, because we're not interested in y, because there are no y's, this is simply x and a function of x. The vertical axis is quite simply x plus 1. So for whatever x coordinate we have, the y coordinate, if you want to say, is simply whatever the x coordinate is plus 1. Now, if we consider our linear function, we can visually see that for every single x coordinate, or every single x value, we basically only have one vertical or y coordinate. And so we could basically say that this is a one-to-one function. For every one x value, there is one y value, or one output. So let's consider the different types of mappings we could get. Right, so we've just discussed x plus 1 as a linear function. And this linear function is a one-to-one function. For every one x value, or for every input, there is one output. If we have a look at the next one, we have x squared. So let's consider some examples for x squared. Let us consider, what if x was equal to 2? So we could write this in function notation or in a mapping notation as x is mapped onto x squared. If x is equal to 2, then we will get 2 squared, which is 4. So we could represent that as 2 and as 4. However, minus 2 squared will also give us 4. So we could have minus 2 also equal to 4. And so if we look at this graphically, we can see that we have multiple inputs that give us the same output. And for this we would call a many to one function. So there are multiple input values that we can put into the function, but they still result in only one output value. Okay, the final example we're going to look at is the function of these plus or minus the square root of x. So before we even consider the function plus or minus the square root of x, how would we even get there? Well, if we had a function y squared equal to x, and we wanted to solve for x, we would have to say, well, y is equal to plus or minus the square root of x, because both the positive and negative number would give us the same result. So in this case, if we consider the function x is such that it's mapped onto plus or minus the square root of x, let's say x was equal to 4, well, positive square root of 4 is going to be 2. And negative square root of x is going to be negative 2. So if we go back to our graph now and we look at this visually, if x was equal to 4, well, we could either have y equal to 2 or y equal to negative 2. And in this case, we can see that for a single input, we got multiple outputs. And we can call this a one-to-many function. Right? So we're mapping one input to multiple outputs.